I am Liz, and I am one of the co-founders of Carbon Cell, and we are on a mission to make polystyrene waste, like what you can see behind me right now, a thing of the past. I probably don't have to spend a lot of time, particularly in this room, explaining why polystyrene is bad. We all know that it takes petrochemicals to make, it takes hundreds of years to degrade, it can photodegrade and leach harmful chemicals into the environment. And despite what the manufacturers might tell you about it being recyclable, it's not very widely recycled. But despite us all knowing that, the fact is that demand is not really slowing. In fact, this year alone, we're going to make enough of this stuff to fill the equivalent of 141,867 Olympic swimming pools. It's a lot. Legislation is beginning to catch up with things like single-use plastic bans, but the reality is viable replacements for EPS have been really hard to find. In fact, in Australia, where they've put in pretty aggressive targets to phase out the material, manufacturers of brands have come back and said, what are we supposed to switch to? There's no way we can meet these targets, but that's where we come in. So Carbon Cell is a foam that is carbon negative, it's non-toxic, and at the end of its life, it can be composted in home composting settings. Our patent-pending technology allows us to create a rigid expanded foam from biochar that is thermally insulative, lightweight, strong, while remaining compostable. Carbon Cell has a negative greenhouse gas emissions factor because of the biochar we use. You just heard about biochar from Dan, and I'm happy to answer any more questions about that and how we got to this number after the presentation. If you look at us versus the competitive set, we compete with leading-edge eco-materials like mycelium foams. But we have a key advantage that our manufacturing process is much more similar to EPS. We expand with heat in a mold in a rapid fashion, so we can compete on manufacturing and scale up. We also are headed up against cardboard, which is probably the biggest player in the eco space right now, very affordable, very widely available, but not very strong and not very carbon negative. And then, of course, against EPS, we have our carbon negativity, and we're competing on affordability and compression strength. If you do the math, using Carbon Cell instead of EPS could result in a 3.7 kilogram reduction in CO2e for every kilogram of material used. And it's 3 times stronger than polystyrene, which gives us a key advantage in the beachhead market we're targeting first, which is electronics packaging. We found through our customer discovery there's a clear unmet need here where protecting goods from drop and vibration, it's just not something that pulp can effectively do with the strength that it has. With a licensing model, we can achieve scale while protecting our IP. So we take biochar from our biochar suppliers, we process it into a patent-pending precursor, and then we sell that to expanded foam manufacturers who already have the equipment set up at scale to make this stuff in large quantities. So for 2024, we have 3 key development activities. We are doing prototype testing with 4 pilot partners. We are testing our manufacturing scale-up with our manufacturing partner here in the UK. And then we have 2 Innovate UK grants, which will allow us to test with end users and broader stakeholders in the packaging landscape. We are a team of engineers, strategists, and designers with a passion for sustainability and over 20 years combined experience in business. We all met while on a master's course here in London at Imperial College and Royal College of Art. And we were united by this problem and growing up by the sea and seeing it firsthand. And this is what it looks like. It's pretty bleak. And the reality is that polystyrene pollution could triple by 2040 if no action is taken. But the good thing is, with your help, we can act now. And if you're interested in helping us on that journey, we're looking to talk to potential pilot customers who want to test the material, anyone who's in the manufacturing space, and pre-seed investors in advance of our round later this year. So thank you.
Liz, thank you very much indeed. And you can now please submit your questions using the QR code on screen. To kick us off, welcome along. So we have a member of your team from Carbon Cell. What happens to the material at the end of life?
When we're done with it, we just throw it into the compost heap outside our studio. And after a couple of weeks, it's gone, which is obviously really satisfying. But there's also the option that it can go into the food waste bin and then go to an anaerobic digester, where the binder will break down, and the biochar has been shown to improve the efficiency and like optimize the digester, which is really cool as well. But like ultimately, we're aware that there's like a number of different scenarios, and all of those will affect the like carbon emission factor. And we're actually undertaking the Innovate UK grant at the moment to explore how our end users would most like to dispose of the packaging, and what the brands want to do, and what the like suppliers upstream want to do. So yeah, the result of this project is going to be we discover what the best way to deal with it, and then implement that. It's really exciting.
A question from the audience asks about the additive that allows it to expand. What is it?
I don't think I can talk about that right now.
Okay, on to the next question. Where do you get your biochar from, and how plentiful is it?
Yeah, we have a few suppliers that we've been testing with that are UK-based that use wood waste, whole tree. They also use mycelium, spent substrate. So after they've grown mushrooms, you can pyrolyze that. There are some suppliers that are using rice husk waste and a variety of other different things. We tested textiles, we tested potato peels. So we're still looking to identify the best supply partner. And then once we have them identified, we would scale up. Ideally, it's located as close to production as possible. So let's say it's in Europe in the future, we would find a European biochar supplier.
How much material are you currently producing, and how much investment do you need to scale, asks another audience member.
Yeah, right now we're producing in relatively small quantities, and you can see some samples outside. Our aim is to scale that up. With a 30,000 pound capex for materials, we can achieve a production capacity of 239,000 kilos of our feedstock. So that's our next step as part of our pre-seed round, which we're targeting later this year.
Okay. Another question from the audience asks about the size of the market you're addressing. What is it?
Yeah, so protective packaging is $194 billion globally. Sorry, dollars, I'm American, if you couldn't tell. And in the UK, it's a bit smaller market, it's 59 million. We would look to expand to Europe imminently to grow that market. And then we're also looking in the long term at the built environment, where EPS and alternative materials like foam are worth the equivalent of $8.6 billion.
Great looking product, says one of the audience members. Are there waste streams from the potential manufacturing processes?
Oh, from our manufacturing process. I guess I don't know who's clarifying that. Well, in our manufacturing process, any offcuts, let's say we're CNCing it, we can reclaim that waste and reuse it. From our manufacturing process, what would you say?
Yeah, because the material has this like amazing property that can be put back into the soil at its end of life and be used as like an amazing soil additive. So we kind of see like the waste stream itself is like just another value add. So it kind of becomes a product in itself after it becomes waste. So yeah, it's kind of the whole thing is like a valuable waste stream. Yeah, and upstream, the biochar itself is made from waste streams from like agri-waste and yeah, waste biomass as well. So it's kind of like different channels of waste coming through.
Does it absorb moisture?
Yeah. So in like a very humid environment, it will start to absorb the moisture. In like normal ambient conditions, it won't absorb any moisture. And also like in the stable form for like, well, we've had some knocking around for a few years now and it's still like very solid, retains its compressive strength. But yeah, in like excess of like 80% humidity, it will start to absorb some moisture, and we're kind of looking into ways we can alter the recipe to address that.
Okay, that brings us to time. Thank you very much, Team Carbon Cell.